Okay. Sorry about that. Um, so let's see how many of y'all are there. Good afternoon, everyone. I think we can get started right away. Let me quickly put a poll question. Are able to see my screen and hear me? Yes or no? Yep, I would request you all to please quickly respond to that poll question. And we'll move ahead. Wonderful. So I'm getting 100% that you all are able to see my screen and you're also able to hear me. Since you're able to see my screen and hear me, I think we should get started. We will also do YouTube live now for this specific session. People who are finding difficulty in connecting via Webinar Jam can also log in to our YouTube channel and proceed further. Friends, to be able to get access to bunch of such futuristic sessions, I request you all to subscribe to our channel. So this is our company, 360digitmg.com. And all you need to do is click on the YouTube channel and you'll have to just subscribe to it. So the session is happening live as we speak. You can subscribe and also click on this icon so that whenever such sessions happen, you're directly notified. Okay, so here we go. I'm just posting the details here. And that's it, nothing much. You just need to do that. We are creating a playlist for the sessions, faculty development program on machine learning on cloud. So we are going to have everyday sessions created underneath this. So there are a bunch of other sessions that we have. Feel free to, watch those. Success stories are, sessions which are connected by our past participants who have got jobs in the space of data science. And we connected our programming session, etc. And we are planning to conduct Python programming session very soon. We'll keep you posted on that. Alongside that, when you go to our learning resources, you'll find interview questions, digital book, mind maps, and bunch of things. So feel free to access those and you can reap the benefits. All right, back to our discussion. So let me quickly do a recap on what we have discussed yesterday. Yesterday, we have understood that there is something called as machine learning on cloud and AutoML, which is picking up. And it is fast picking up. It is picking up to such an extent that, world is saying that even people who don't know how to write a single line of code, people who don't know anything about the math behind the scenes with respect to the machine learning algorithms can still implement AI. And that is going to be future. And on the last day, we would certainly touch upon explainable AI, how you can add value to your projects, to your data science projects. All right, and we discussed the differences between artificial intelligence, data science, data mining, machine learning, and deep learning, and what is reinforcement learning. And we understood what are the benefits when it comes to AI. Again, here is a quick agenda of what we are going to discuss. Today, we are going to spend time on AutoML, and we are going to do hands-on on or using something called as TPOT. TPOT is a library which will automate a lot of things. What are the aspects which TPOT is going to automate, we'll understand that. And tomorrow it will be Amazon Web Services, wherein we are going to explore Amazon SageMaker, and we are going to do a hands-on, okay, on autopilot aspects. There is something called as autopilot. We'll explore that. And the day after that, we would look into Amazon AWS machine learning services. Most probably, we will be building a chatbot using Amazon Lex. This is also another thing that we will explore. Then we would get into Microsoft Azure ML Studio, and we will see how you can just drag and drop the various options, and you can build your algorithm and then deploy it in production. And you'll then move on to Google Cloud Platform. We will once again explore the AutoML option, which is available in GCP. Finally, we'll wind it up with explainable AI. So this is in short about what we are going to do. And we understood about Crisp MLQ, which is slightly different than Crisp DM. In Crisp MLQ, there is a new phase which is included, and that new phase is model monitoring and updation or maintenance. And for that, we will have to look at data drift monitoring as well. And that's what we have discussed, which is very critical and very important. Then there are a few key things when it comes to AutoML. We'll discuss those aspects. We'll discuss about hyperparameter optimization. We will discuss about NAS, automated feature engineering. Right? These are the three things that we shall discuss. And we have briefly got ourselves introduced to the open source tools, or at least we know the names now. And we know the names of those which are commercialized. We would not touch upon each and everything, but we would certainly look into TPOT today. And when it comes to commercial, we would look at Google Cloud AutoML, Amazon SageMaker Autopilot, and Azure Automated ML. These are the three things that we shall discuss. And here we go. Let us first understand on what is the pipeline when it comes to building your models end to end. The first step is data ingestion, meaning getting the data from various sources. Data might be in PDF format, PDF document format, or data might be in Oracle database or any relational database management system, or data might be in an Excel format, or it might be in tabular text format, or whatever format data is in. It could be videos, audio files, or textual files, or structured data, doesn't matter. When you say ingestion, you're bringing in all the data. Okay, you're ingesting the data into your system so that you can perform further activities. So the next thing that people usually do is data preparation. Once data ingestion is done, people move on to something called as data preparation. Here is where you clean the data, pre-process the data, perform various activities to ensure that your data is in the format that is required by the model that you're using. And then you choose, you decide what models do I need to use. There are hundreds of models which exist, algorithms which exist. Which one should you use? In which context should you use? Is something that you have to decide. Okay. Next thing is model training. You train your model, you build your model. After you build your model, you evaluate. And if you're happy with the model accuracy, you deploy it. If you're not happy, then you retrain your model. You retrain your model. Okay. Here, one another thing that you need to remember is once you have data in the required format, once you have done the data pre-processing and once you supply your data to your model, you do model selection, you do model training, and then you do model evaluation. Here is where you look at which neural network architecture is the best. You perform hyperparameter tuning, and if need be, you retrain, or if you're happy, you deploy your model in production. This dotted aspect, which is highlighted, are the aspects or the components which your AutoML has automated. Whatever you see in the dotted stuff is automated, friends, using AutoML. Can the other aspects also be automated? Sure, they can. But for now, heavy emphasis is on this portion where there is a lot of manual effort. And when it comes to AutoML, there are three key things which are very time consuming. When you look at it from a data scientist perspective or AI expert or data modeler perspective, then there are quite a few things which are time consuming, but these are the three time consuming tasks which are automated by AutoML. And that includes automated feature engineering. Yesterday, we briefly discussed about feature engineering. And there are separate libraries, open source libraries which exist, which can perform automated feature engineering. And we also have automated model selection. Automatically, models are selected. Hyperparameter tuning. Automatically, the hyperparameters are tuned. Hey, what are these hyperparameters, etc. Right? I'm expecting you guys to have some brief understanding about data science, okay? But nevertheless, this is the future, so we will just move on. Automated neural network architecture search, NAS, is what people call it as. All these things are automated using AutoML. Model selection. Should I use logic regression?
Okay, hope you guys are able to hear me now, because I will not connect using, okay, I'll not connect using mobile because that's creating some problem for me. So I will rather, okay, yeah, I'll just wait again. I'll take a poll question here. Let me reset this poll and then start the poll again. Now I believe you should be able to hear me, right? Okay, fine, wonderful. So let me move on. I'll track it on YouTube on whether it's fine or not. Okay, so let me uh, look at it here, or write the things here. So for model selection, would you manually, obviously you can figure out which algorithm suits your data and then manually select different algorithms. Having said that, we want to automate these things because it will take a lot of effort for a data scientist to decide different algorithms and run different algorithms on the data. Instead, can AutoML automatically choose different algorithms and then figure out which one is the best? And do you know what? AutoML has the capability to decide appropriate algorithms based on whether your output variable is continuous. For example, say you want to predict salary of a person who is getting trained on data science. Here, the output variable is continuous. So there are different set of algorithms which can be applied on this. And if your output variable is categorical, meaning whether a person will be infected with COVID or not, upfront predicting, or by looking at the X-ray of your lungs, can we classify whether a patient is going to be COVID positive or negative? It is categorical. Based on what your output variable is, AutoML has the capabilities to decide what algorithm works well on that specific use case or on that specific business problem. Next is hyperparameter tuning. Let me take just an example of maybe neural network algorithm. When it comes to neural network algorithm, you will have input layer. Okay, this is called as input layer. This is how the architecture looks like. And then you'll have hidden layers. When it comes to hidden layers, you can have one hidden layer or two hidden layers, or you can have three hidden layers. The number of neurons you can have could be 3, 4, 5, 6, 700. I mean, there is no specific number of neurons that you need to define in your hidden layers. These are your hidden layers. How many hidden layers do I need to have? How many neurons do I need to have in the hidden layers? Right? So on and so forth. All these things are hyperparameters. Number of hidden layers is a hyperparameter. Okay. Number of neurons in each of the hidden layer is also a hyperparameter. Now, how many would a data scientist experiment? And how will they experiment? It is going to be a huge time-consuming activity. Data scientists can rather spend their effort on something which is beneficial, as opposed to spending their time in doing all these hyperparameter tuning, deciding upon which algorithm is the best and all that, right? And here we have AutoML, which automates this task as well. And this task, neural network architecture selection. If your output variable contains or if your data set rather contains images, then we have to use convolution neural network. If your data set has textual data or time series data, then the neural network architecture that you need to use is RNN or LSTM or GRUs, gated recurrent units. If your data is structured, you might end up using MLP, multi-layered perceptron. Which one should I use? When should I use? Which algorithm, which neural network architecture will make more sense? All these things are usually done by data scientists. But with the advent of AutoML, these things are also automated. How cool is it? Yeah. So the major things which require good understanding of different machine learning algorithms, the different options which exist in the machine learning algorithms, yeah, neural network architectures. I mean, people with good understanding of these can manually do it. But what if someone is not aware of all these things? Can they still implement machine learning algorithms? Sure, they can. And that's the revolution which we are talking about. And by no means this is going to take a backseat, friends. Heavily this is being used in the industry now, right? It is going to revolutionize in the next 1-2 years. I would say in the next 1 year. Okay, so AutoML, here we go. Data preparation, to a great extent is still a manual process. Okay, because it really depends on how your data is, etc., to be able to, do some data cleansing. But when it comes to data cleansing or pre-processing, outlier analysis, right? If you have outliers in your data, this is automated. If you have missing values in your data, you impute or you perform a technique called as imputation. Yep, that is also automated within AutoML. Then you have feature scaling, normalization or standardization. That is also to a great extent automated, right? Then you have feature engineering, wherein you have feature extraction, feature selection, feature construction, so on and so forth. This part is automated. And model selection, hyperparameter optimization. These are all the various techniques which exist when it comes to hyperparameter optimization, but those are automated. And model evaluation part is also automated, friends. So the way data scientists work on machine learning algorithms, the entire scenario is slowly changing. And then let me briefly talk about a few more things before we get into the hands-on. Automated hyperparameter tuning or learning of hyperparameters for a specific model is sometimes bundled with learning the model itself. Learning the model itself gets combined with hyperparameter tuning, and it forms part of a bigger term which is called as neural architecture search area, and this is widely called as NAS, neural architecture search. And this approach is also known as full model selection. That means not just selecting your specific model, but then it will also decide on what should be the hyperparameters. Okay, and or combined algorithm search and hyperparameter optimization, cache is what people call it. And this NAS is also known as automated deep learning, AutoDL, or simply a few people call it as architecture search. These are a few terminologies which maybe you should be aware of. Okay. Next, when it comes to automated model selection and hyperparameter optimization, you have a few specific techniques such as grid search technique. What happens in a grid search technique is, when it comes to neural network algorithm, you have hyperparameter, which is learning rate. Learning rate is one hyperparameter. Dropout is another hyperparameter. Hyperparameter is that option within an algorithm which you can keep changing to experiment. For example, you can change learning rate. Learning rate values range from 0 to 1. In between 0 to 1, you can choose any bunch of numbers and experiment. So since you're allowed to change a value and experiment, it is called as hyperparameter. Okay, and then you can take, or you can get different values. You can choose different values. For dropout also, you can choose different values. This also, for dropout also, it ranges from 0 to 1. Usually people do not choose 0 or 1. Okay. And if you're selecting these, then what happens is, when you say grid search, it looks at all the combinations, meaning learning rate 0.1 and dropout 0.2. It will build one model. And accuracy of this model is captured. Then learning rate 0.01, and then dropout 0.2, and another model is built. Accuracy is once again calculated. This is point. And then learning rate 0.1 and dropout 0.5, 0.1 and 0.5. Another model is built and accuracy is calculated. Then learning rate 0.01 and dropout 0.5. Another model is calculated. So for all these models, all the accuracies are calculated. And then your grid search algorithm is going to give you which is the best combination. That combination which gives you the highest accuracy is obviously the best model. Okay, that's how it is built. If you feel that, if I give learning rate as 0.1, 0.2, 0.3, then 0.001, 0.002, 0.003, then 0.01, 0.02, 0.03. And then if I give dropout, multiple values for dropout, and then if all these combinations of models have to be built, it would be very time consuming. It will consume a lot of time. Hence, people came up with something called as random search. So what it will do is, out of all these combinations, random search will randomly choose a few. Maybe it can choose only this and this. And then it will, out of these two models, give you the best result. The disadvantage with the random searches, you may not get the best model because you're not executing all the models, you're not running all the models. But the advantage is it'll be faster and cheaper. The reason why I'm calling it as cheaper is because when you run this algorithm on cloud, you'll have to pay to the cloud. Okay, or if you're running it on premise, you need data scientists to take time out, run it. While it's being run, they have to sit idle. So all that is cost, because every minute you'll have to pay to your resources. And then you also have something else which is called as Bayesian search, something else which is called as hyperband, and there are a bunch of other techniques, but these are most widely used. okay, in helping you decide what is the right model and how do you decide or how do you get to understand the right hyperparameters. Why am I explaining all these things? Because I'll run hands-on, I'll do hands-on, and suddenly you'll get the result. Your TPOT library will take care of everything. You should not be surprised, hey, how is it actually doing all these things? That is the reason why we are trying to understand the science behind the scenes or the theory behind the scenes. I'm not delving deep into theory, but at least at a high level, you should be aware of these things. Okay. Then we have NAS, Neural Network Architecture Search. This is very powerful. Okay, it decides on how many layers do you need to have, how to stack those layers together, right? What kind of deep neural network architecture makes sense? And when it comes to NAS, it has three main components. One is search space. What are the various combinations of architectures which exist, from which your AutoML should pick up one best architecture? And this search space is space where you search. All the neural network architectures are available in that. So it consists of set of blocks of operations. Do I need to use a fully connected network, dense network, multi-layered perceptrons, or convolution neural network, or recurrent neural network, or autoencoders? Which one should I use? If I ask a data scientist to decide, sure, someone with knowledge can do that. But can I have someone without knowledge also build a model? Yes, that's the goal of AutoML. Don't worry about algorithms and all that. Just supply your data, you'll finally get an output. And how these operations are connected to each other to form a valid neural architecture. Okay. So when it comes to convolution neural network, you'll have the input layer, you'll have convolution layers. How many convolution layers do I need to have? You'll have max pool or pooling layers. How many of those do I need to have? So all that is decided by looking at the search space when it comes to NAS, neural architecture search. Next, you have search algorithm. NAS search algorithm tests a number of candidate neural architecture models, all the models. And then it will start calculating the accuracy and loss metrics, various metrics. And then it is going to decide one candidate algorithm or model. Candidate means some algorithm, which gives the highest performance, obviously. Right? Something which gives the highest accuracy. And then it will also decide upon the evaluation strategy. Since you have a large number of models and you need to test a large number of models to become successful, the process is computationally very expensive. Too many options to be evaluated. So there are new methods which will help you save time, which will use less of your resources, or they'll use your resources for less time and yet help you achieve the end objectives. Okay, next. So this is the NAS architecture. Typically, I'll not get deep into this because this is a new area of research. People who are planning to pursue their PhD, postdoctorate research can focus on NAS and AutoML. This is going to be the new normal. Right? If I were to speak in terms of COVID, then this will be the new normal moving forward. Okay, you have NASnet. I'll leave it to you for you guys to explore more and read more. You also have AmoebaNet, which is also very famous. And then you have Efficient NAS, which is also famous. These are all, a few things which are still in research. Okay. I'll just skip this part. Okay. Two things which you need to bear in mind is that when it comes to hyperparameter tuning, please do not get confused with internal parameters versus external parameters. Internal parameters, which are also called as model parameters, are internal to the model. For example, if you're building a regression model, you get an equation like this. Y is equal to beta naught plus beta 1 x1 plus beta 2 x2, something on those lines. Right? All these beta values are called as parameters. If you look at neural network equation, this is how it will be. And these values, B stands for bias, W stands for weight. These are also called as parameters, which are internal to your model. Weight matrix, predictor matrix, etc. And also you have external parameters which are outside of the model. Like you have learning rate, number of hidden layers, you have batch size, so on and so forth. These are external, and these external parameters are called as hyperparameters. So there is a difference between parameters versus hyperparameters. Please do not get confused. Okay. Pranay, what link are you asking for? I see that Pranay has asked a question on YouTube channel chat twice. Please share the link. What link are you expecting? Please, can you be a little specific, Pranay, on that? Okay, while Pranay gives me that, let me look at the chat. Sambit asks a question, what is dropout? And then, is there any other question? Please help us know. Okay, model selection will be done on the type of data we have chosen to work on. Yes, Siva Prasad, you're absolutely right on that. And is a general problem. I didn't get what you mean by that, but Sambit, to answer your question, whenever you have neural network algorithm, right, you will have a network like this, assume, and all these would be connected like this. All these neurons will be connected to one another. And if I say dropout equal to 0.5 as an example, then what will happen is randomly 50% of the neurons in this, 50% of the neurons in this, and 50% of the neurons in this would get disabled. Okay, this is a technique which is used to avoid overfitting and all that, without getting deeper into that. Right, next. All right, so these are the various, algorithms, open source. A few are written in Java, or rather only one is written in Java. Rest all have been written in Python, and Python is fast picking up. So let's get into the first library, or the only library that we will discuss as part of this, FDP program would be TPOT. Even before we proceed further, friends, there are 4 levels of automation. The basic automation, which is achieved using robotic process automation. That is why RPA did not take off in a big way. When it was introduced, people were like, oh, RPA, robotic process automation, that would be the next big thing. It didn't take off because it was just trying to automate the basic stuff. Then you have techniques which will automate your process. Then you have techniques which will integrate the automation into the process, and wherever systems are integrating or talking to each other, that aspect also can be automated. And then you have AI automation. This AutoML is at this level. AI automation. That's a big thing. Okay. Now let us take example of one simple algorithm called as XGBoost, extreme gradient boosting, which I would say is number one in the traditional machine learning algorithms space. So you have traditional machine learning algorithms, and then you have deep learning algorithms. These are the two broad categories which exist. Of course, you have reinforcement learning, ensemble, and all that. This XGBoost is the best today. If you ask me, hey, name me one algorithm which is the best as of today when it comes to giving you good accuracy, XGBoost. A lot of competitions are being conducted on Kaggle and various other forums. And people who are winning the first place are people who have used XGBoost. And then you have deep learning algorithms. That's a different ocean altogether. So let's take XGBoost as an example here. If you use XGBoost, and if you look at the various, I would say, hyperparameters, then you'll have something called as booster, verbosity, validate parameters, nthread, this. Just think about how complicated, or how many options XGBoost has. These are not many, right? Only 1, 2, 3, 4, 5, 6, 7. And do you know what? Interestingly, a few of these are automatically selected by algorithm. The default options that are assigned are automatically assigned by the algorithm. So you need not even worry in deciding what each one of this should be taking, what value each one of these should be taking. But then, if you choose in booster GB tree, I mean, you can choose various options here, and say you have chosen within this booster an option which is called as GB tree. Now, the moment you do that, you will have multiple other hyperparameters to experiment with. And do you know what? All these are the various options, my dear friends. Eta value, gamma value, maximum depth, minimum child weight, maximum delta step, sampling method, lambda, alpha, tree method. Oh my God. All these will take multiple values. As a data scientist, only if you're aware of all these things, only if you're aware of what each one of these hyperparameter does, you can select the options. What if there is someone who doesn't know anything about these, yet they want to implement AI? Can they do it? Certainly they can. That is where your AutoML and TPOT comes into picture. TPOT is an open source library within AutoML. Okay, and we will explore that further. And before I proceed further, I have a quick question. Let me put a poll question here. Okay, Mallikarjuna daily sessions will happen. Okay, from 2 to 3:30 until Saturday. Yeah? So probably you can attend that. But then maybe we should have also posted. Munidhan Lakshmi, see, again I need to explain XGBoost for that, and again I need to explain how does XGBoost work and all that. So it will divert our attention. from AutoML. Okay, so that's taught exhaustively in our data science training, full-blown training, but here I'll unfortunately not be able to touch upon those aspects. Okay, friends. But okay, here is a poll question. Are parameters internal to model or external to the model? Internal, external. Please, can you all answer this? There we go. Yeah, that's the poll question. I request everyone to please respond to that. Come on, friends. Who is answering what that is anyways not captured? I just want to know how many of you all are attentive, how many of you all are able to follow the session. Okay, wonderful. So 88% of you all are saying that parameters are internal to the model, and that is right. I have yet another question for you all. Are hyperparameters internal to the model or external? Please, can you all answer this? Yeah. Yep, we should have maybe published it, Madhukachana. But every day, same link, everything would remain the same. Exactly. People on YouTube live are also responding. Thank you, friends. I'm making a note of that. Yeah. So it is external, friends. Okay. Hyperparameters are external. Parameters are internal. Just remember that. Hyperparameters are external. Parameters are internal. Okay. So what are the different aspects which are automated by your TPOT? TPOT stands for tree-based pipeline optimization tool. Okay. And the moment you get the raw data, you clean the data, and once you clean the data, you perform feature selection, processing, and construction. And then you build your model by selecting the right model, and also you perform parameter optimization. The area which is highlighted in dark gray, those are the things which can be automated or which are automated. So these three fall under feature engineering. Feature selection, processing, and construction are part of feature engineering. And then you have hyperparameter optimization. And NAS would encompass these two. Neural architecture search. And those are the three things which your AutoML would automate. Okay. And once everything is done, what do? You deploy. Either you do an offline deployment or batch processing, or you do real-time online processing by deploying your model. Yeah, Nagamalakshmi, you can post your questions on YouTube also. I'm having a close watch on that. But something related to machine learning, please, because or this AutoML. Okay, so these are the things, friends. When it comes to machine learning, supervised learning, You will have regression tasks when output variable is continuous. You call this specific business problem as regression problem. If your output variable is categorical, you call this specific business problem as classification problem. And these are the various algorithms which are part of your TPOT for classification. Okay, and then these are the various feature pre-processing operations which are applied. And these are the feature selection techniques which are available within TPOT. Let me see if good. Yeah, and this is the last slide before we get on to the hands-on. Get to hands-on. The default TPOT settings are like this. It runs 100 different algorithms with 100 different population sizes. Okay, and most often than not, you come across these common issues that your TPO optimizer did not converge because it will run for a specific amount of time. And within that time, it will try out different models with different options. And there are multiple optimal pipelines which exist. This is also another issue because, yeah, obviously, there is no single set of techniques which always will give you the best result. There can be multiple techniques which can give you the best result as well. And TPOT can be used to handle the following tasks: regression, classification, parallel training. And so without wasting a lot of time, we would quickly jump into TPOT. Okay, so just give me a minute while I get into TPOT and show you. The required data sets we shall share with you all. Okay. Towards the end, I'll let you know on how you can get access to that. But now I'll do one thing. I'll open Google Colab. Google Colab is, the free version is also available. This is as simple as running your algorithm on cloud. Right, so I have this already available. So I'm opening that directly, but then for y'all, when you go to Google Colab, it would maybe pop up a window like this. Even if it doesn't pop up, I'll cancel this. This is how it would be. You can just click on File and click on New Notebook. Once you click on New Notebook, this is how the screen would appear. You can give a logical name. You can say AutoML, working on TPOT. .pynb is Python notebook. And then you have an option here called Connect. Before connecting on that, click on Runtime. And you have an option called as Change Runtime Type. Click on that. And within the drop-down here, select an option which says GPU, Graphical Processing Unit, or select TPU, Tensor Processing Unit. And Google will automatically allocate you one of the available GPUs or TPUs for processing. If you select none, your algorithm will run on a CPU machine. So I'll select GPU and click on Save. Now, if you click on Connect, you will, it connected, and you can start typing. If, for example, if I type 1 + 1 and click on this icon Run, it will show you that result is 2. If you want to add another line of code, just click on that code. Type whatever you want. Import NumPy as LP. Done, it got imported. That's how you make use of that. But that's not our goal. I'll come here, I'll click on connect. Oh, it says that you need to upgrade to Collab Pro to be able to use more sessions, but we don't want parallel sessions. That's okay. I'll click on manage sessions and I would terminate this session. Okay, this part I've terminated. All right, now let me click on connect and it's going to allocate resources, appropriate GPU for me. It's initializing connected, right? And is it GPU? Let me cross check by going to runtime, change runtime type. Yep, it's a GPU machine. Previously, I selected that. Okay, friends, pretty simple, okay? TPOT is a library which is actually introduced to us and it is a product of University of Pennsylvania. They have computational genetics lab. This is introduced by them. And this is written in Python, TPOT. They have built this product using Python. And you know what? It is built on top of the famous scikit-learn library. And scikit-learn is Python or Python's machine learning library. It has all the machine learning algorithms within that. So TPOT is built on top of this. So that means you can make use of all the benefits of scikit-learn or all the functions in scikit-learn alongside use the unique features of AutoML of TPOT. Okay. So first things first, you need to install TPOT. Okay, just click on this. This exclamation mark is just Google Colab's way of installing. Even if you don't give that exclamation mark, still it works. Oh yeah, so successfully installed TPOT. Within this TPOT, you have TPOT classifier. Of course, you can also make use of regressor, etc. And you can run this. And I'm going to go to scikit-learn, which is a machine learning library of Python. Within that, you have something called as datasets. Because I want to use some data set which is already available and I want to build a model on top of that, and I'm importing load digits. Load digits will actually import a specific data set which is all about recognizing handwritten digits. It has 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all these numbers which are handwritten. And you need to classify, given a handwritten digit, you need to classify that it belongs to 4, or given a handwritten digit, you need to classify that it belongs to 3. That's the problem, and that's this data set. Okay, and I'm also importing something from scikit-learn model selection, and I'm importing train test split. So let me click on that. It's executing that. Do you see that small red green icon? It says that all these are being done. Warning messages, yeah, don't worry too much about that. They will be deprecated, meaning removed in the future version, supposedly. That's fine. Next, you have this data set which you imported. You're loading load underscore digits. You're loading that into an object called digits, and then you're saying this digits will have two things. One is data. Data is collection of all your inputs, and you also have within digits target, which happens to be your output variable. This is the only time you will see code, friends. I mean, code programming. This is the only day that you'll be seeing. Probably for the next 15-20 minutes you'll see. But from tomorrow onwards, it's all these things are automated. I'm just showing you because if you understand this, you will understand how people in Amazon, Microsoft, and Google have actually been able to automate the entire machine learning pipeline. You'll understand that aspect. That's the reason why only for once we will run this, just to help you understand, better the concepts that we're going to discuss from tomorrow onwards. Okay. And what we are doing here is we are saying training size should be 75% and test size should be 25%. So you're splitting the data. Let me run it. So what happens here is it has split the data, and from this, these are inputs, right? So from this training data set, which is 75% of data, and 25% of the data, which is test, would get stored in this. Then when it comes to digits dot target, 75% of the data would go here, and 25% of the data would go here. And then you're looking at the shape. 1347 observations and 64 columns training. 450 observations and 64 columns in your test. And if you look at your output variable shape, 1347 output variables exist. I mean, this is how it would be. 1, 2, 3, in that way you have 1347 observations. This is your output, which is y_train.shape. And then 1347, 64, 1347 rows, and you'll have x1, x2, x3. In that way you'll have 64. And then in test data, you have 450 observations, and then 64 x1, x2, x3. Here also, if you take output variable y_test.shape, you will see 450. So 450 would be there. Okay. Now this is just given for your understanding that it will have generations, population size, offspring size, so on and so forth. These are all the parameters or arguments which are part of your TPOT class. It's just given for your understanding, that's it. All you need to do is run this. TPOT classifier, when I say verbosity equal to 2, it will show this optimization progress and how many techniques have been applied, how much time it has taken. It will give you more information. And you're saying maximum time in minutes should be 15. So you're saying run it for 15 minutes. Within 15 minutes, whatever best algorithm is built, that is fine, is what you're saying. And you're saying try out 40 different combinations. And then TPOT, you're storing all these things in TPOT. When you say TPOT.fit, you're actually running your model. And when you actually run your model, you have to give your inputs and output. Okay, once you build your model, you also want to test it on the test data. So you're saying TPOT.score, the rest is on the test data, and print out the accuracy value by testing on the test data. So let me run this. While this happens, I'll just tell you what's happening here. So what we have done is, ideally, friends, we have taken the data and we have split that into training and test. And I've shown you that we have taken 75% of the data into training and 25% of the data into test. And then you're building a model. To build a model, you need to give various options, and these are the options that you're giving and storing in this. But that model gets triggered only when you say TPOT.fit. And whenever you build your model, you need both inputs and output, because your model will learn the patterns between output and inputs. It will learn the patterns. For example, if it is whether a person will default or not, what is the age of the person, what is the gender of the person, what is the income of the person, what is the educational qualification. Say age is 32 years, gender is female, you know, income is 1 lakh rupees per month, and then education is say post graduation. Given all these details, person maybe will not default. Another person's age is 36, male, 50,000 per month, graduation. Maybe person will default. So it will learn such patterns. Given the inputs, what is the output? More the data, more patterns your model will learn. At the end of the day, building model means learning patterns between input and output. Okay, so once you build your model, after this is done, it will build the model. Then you test it on the test data. So until now 75% is done. It will run more. Okay. And how are you testing on the test data? Using this function, tpot.score. In test data also you have inputs and output. You are supplying test data inputs and outputs. So it will test and figure out whether your model is accurate or not. Okay, and then finally you will get the accuracy. So 95% done, hopefully 99% done. Let's see how quickly it is going to accomplish this. Though we have given 15 minutes, within those 15 minutes it will do whatever best it can. Yes, Nagama Lakshmi, TPOT can be used for regression tasks also. Next question is, will it be automatic? Not like your AWS, etc. In TPOT, to that extent, it is not automated. But then what techniques, what algorithms should be used, what hyperparameters should be used, those aspects are automated within TPOT. Okay, another question from Nagama Lakshmi is, generally, why training data and testing data ratio varies so much, and how we will know that how much ratio should be for training and how much accuracy. Okay, so when you appear for exam, that is like test. When you appear for an exam, would you get less questions or more questions than what you have trained yourself on? You would have trained yourself on the complete textbook, all these sample papers, etc. So obviously training should be and will be on more data, because your model is learning the patterns. In test, you're just testing whatever you have learned. Are you able to implement it properly or not? Are you able to predict properly or not? So obviously in test data, you'll have less data, right? When someone wants to test you, they won't give you the entire textbook, right? So that's one thing that you need to remember. And what proportion, it's up to you. There's no hard and fast rule that it should be 75% in training and 25% in test. It could be 80 and 20%, 90 and 10%, or 70 and 30%, or 60 and 40. It's up to you. More the data in training, better will be your model. More the data in test, more will be the confidence that, yeah, I tested on huge data and my model is working well. You'll have more confidence. Okay, that's another thing. And while this builds, let me quickly check whether our friends here have any questions. Okay. Can you please zoom it? Yeah, sure, Kavita, I'll do it. Yeah, Chandar. The process is to do pre-processing also, your model takes care of. You can zoom it from your browser. Yeah, thank you, Ananda. Because on YouTube, it's pretty good. All these when we have time to practice. When can I didn't get your question. Friends, what would you do if I zoom it? Do you want to practice it along with me? Sure, you can if you want to. But not sure why you want to do that. Because you can focus. Anyways, the recorded videos are available on our YouTube channel. You can watch that. Okay. You need not do along with me. Because what will happen is you'll miss out on important things that are being discussed. For the rest of your life, these videos will be on YouTube. Okay. Until unless Google says I'm going to shut down YouTube. So don't worry. You can obviously, zoom in, zoom out. You can do all those things. Okay. Don't worry too much about font. Yeah, I increased it. If I increase certain aspects which are given here, you'll not be able to see. But for now, I think this is fine. Zooming it. Okay. So it's running. Generation 1, generation 2. We will wait for, 15 minutes. I should have given maybe only 10 minutes, but let's see. So after the generation 1, it achieved an accuracy of 95%. After generation 2, accuracy is 97%. So it improved. And are you changing different algorithms here? Not really. Your algorithm is automatically doing it for you. It is trying to figure out different algorithms, different hyperparameters, and then it will spill out and give you the best, technique out. So we will wait for maybe another 5 minutes, and it should be done by then. Okay. So I would recommend that we take quick 5 minutes break only, and we will connect back at 3:20. When we connect back at 3:20, this algorithm should be done, and we will then proceed further with the next steps. I'll be on mute. Okay. Is this process like finding the optimized model from the different models? Exactly, Santosh Chandra. Can Rishabh says, can we do unsupervised learning using TPOT, and if yes, then how? No, you cannot do it. Okay, Santosh Chandra, very good. Very good. Okay, I'll be on mute. Yeah, sure. That's a good thing, Santosh Chandra. That's a good thing. Let it complete on my machine, and then I'll show you. But you got your models got executed. Okay. Yeah, it is clearly written on the screen, right? Santosh Chandra and Sirisha that okay, please connect at 3:20. You're saying no audio. Okay, anyways. So let's move on. And so we thought that we'll connect back at 3:20 because the algorithm was running, right? Rather than wait, we thought we'll take some quick break. Now 4 generations are done and done. 15 minutes, 18 seconds has lapsed and TPOT will close down is what it said. TPOT closed during evaluation in 1 generation. It prematurely closed. Fine. But it found the best pipeline. It is saying that logistic regression with polynomial features, degree 2, right? And these are all the various arguments or hyperparameters have been selected. And you're getting the best accuracy as 97%. Different people will get different results depending on how powerful their computer is or what kind of GPU Google has allocated to them, because Google randomly allocates based on that. Okay, next. Just a minute, I've lost it. Selected. And you're getting the, yeah, wonderful. Now you'll have to mount your Google Drive. This is how you mount your Google Drive, because the model that you just built, you want to probably save it on your Google Drive. So I'll say from google.colab import drive, and you do this. When you do that, your drive gets enabled. So you need to click on this URL and it opens this. You can select your drive, you can sign in, and then it will give you a code. You need to copy it by clicking on this, and then you need to paste it here and click on enter. Then it authorizes. Yeah, that is how you authenticate. And your Google Drive will be mounted. I'll not run these two. These two are for 5 minutes, 15 minutes, again the same thing. I'll not run that. So once it is authenticated, it says mounted. Then what we are going to do is we are going to save our model. Whatever model we built, we are going to export it. TPOT underscore digits underscore pipeline dot py. So you're exporting it and loading it on your drive. So let me click on this and show you your drive. So here, do you see TPOT underscore digits underscore pipeline? When you run this, it temporarily gets saved here on your Google Drive. Then you have various libraries, import numpy as np, pandas as pd, whatever libraries you want, you can import that. And our pipeline is slightly different here. If you see, it's logistic regression, polynomial features. So I need to import logistic regression for that case here. But nevertheless, let me run this. And here, if you want to know which is your best pipeline, you need to click on this, and then it will show here on what is the best pipeline. And it will also tell you what you need to import. So just copy these. Okay, if I zoom, this is what happens, friends. So please don't ask me to zoom. Okay, this code will anyways be shared with you all. So you paste it here. Whatever libraries have to be imported, your model is readily telling you. And whatever is given here, exported pipeline, make pipeline, right? Copy that and paste it here. I didn't copy it properly. Let me copy it and let me paste it here. That's it. So after that, you can close this, and I'm going to run this. Exported pipeline. So whatever is a final model, you're taking that and storing it in an object called best estimator or best model. See how simple it is. You need not even worry. Okay, and if you print what is the best model, it says that logistic regression with these various parameters, hyperparameters, is giving you the best result. Did you experiment? Do you need to know when you ran this? Did you actually worry about which algorithm should be implemented? What is the C value, class weight, dual? Did you even need to worry about these things? Not at all. Your AutoML has taken care of all that. And it is just saying that, hey, this is the best model. Take it and readily use it. And here what we are doing is, we are importing matplotlib.pylab pyplot as PLT because we want to just visualize this image, the first image. Remember, the data set that we are dealing with is handwritten digits. Okay, and then you have this handwritten digit which is available, which happens to be 1. Now what we will do is, we will say okay, I'll just import another library called as import joblib, and we will see what this will be predicted as, this will be classified as. Let me run it. Okay, so what it is doing is, it is again splitting the data into, training data and test data. Here you have taken 80% as training and 20% as test. You split the data by loading the digits, and whatever is your best pipeline, best model, you're taking that best model and you're saying fit on that data set. And then you want to store the results. You want to predict using your model on the test data, and then you want to store the results. It's throwing some error, some warning message, just ignore that. And then you are saying print the number is predicted to be, and it's saying that the number is predicted to be 1. And this handwritten digit is also 1. And it's showing that it is 1. That's how it is. Okay. And then using this function joblib.dump, you're taking your best model and you're storing your model in a format called as .pkl. Pickle format is what they call it as. Whenever you want, you can load this pickle format and use it. So if I were to click on this, look at that, digits underscore model.pkl. That is the ultimate model that you saved. You can give it to your software developer who will deploy it wherever you want. Maybe they'll deploy it in on Python Flask or some other application which will give you that user interface. All right. So tomorrow we will not be doing even a single thing. Okay, there's a question. When we split our data set as 75%, 25%, all those data cannot split same for multiple times. So, or how many times we need to test it until we get accuracy? Because we have hope on next attempt. I didn't quite get you, Chandar, but yeah, to answer your question, you split your data set multiple times and test it on the test data multiple times, take all the accuracies and take an average of that. Siva Prasad says, as you said, it will give us an approximate time to complete, not the accurate time to execute. Because the time we get here around, yes, exactly, Siva Prasad. You gave 15 minutes, it just slightly extended 15 minutes and it has taken 15 minutes, 18 seconds. If you run it for 1 hour, sure, you'll get even better results. Okay, so friends, once again, I repeat, if you want to get access to these, it is available on our YouTube channel. Just go to 360digitmg.com, scroll down, you'll see a link there, click on that. It will take you to our YouTube channel, click on subscribe and this, and you'll be able to attend n number of such sessions which we conduct. All right. Thank you all so much. And tomorrow it will be AutoML. We'll connect and take it forward. Thank you, friends. And bye for now. Everyday class will be there on a YouTube channel, Sambit. Everyday class will be there on a YouTube channel. And please give your attendance, friends. There is a link which is posted. We want you to, give your attendance and give your feedback as well. Thank you all.